Oh, we'll be talking about equation of continuity. Okay, and we'll be talking about mass flow rate. Okay, we're talking about volume flow rate. Okay, all right. So when we have a pipe and you have different cross section, let's say this cross section is A2 and this cross section is A1, and you expect this fluid has velocity V1 and then velocity V2. Okay, so we're going to assume it's incompressible, right? So now I'm going to change color. So if I look at this amount of delta M here, so sometimes later this delta M will be here. And the delta M should not change, right? And let's say this time from here to here, it took delta T time. So the mass flow rate, right, is delta M divided by delta T. Okay. So delta M, what is that? Delta M is Zo, right, times V, right? And this V here is volume, right? So the volume here. So the volume here, I'm going to call that V, is equal to A1, and we're going to give a distance here, right? And the distance, I'm just going to call that L1 here, okay? So the V is equal to A1 times L1. The V shouldn't change too, right? Because it's incompressible. So the V here is equal to A2 L2, right? So this is L2 right there. That's your L2 there. Okay? And Zo is constant, right? Throughout. This is Zo, the density. All right. So Zo times V is it's the mass, right? And then divided by delta T. Okay. So we're going to put that in. Zo A1 L1 delta T. It's equal to Zo A2 L2 delta T, right? But delta T, L1 divided by delta T, we're going to call that V1, right? So that's the velocity. So distance divided by time, right? And this is L2 divided by delta T. And that's your V2 right there, okay? Because the pipe is wider, so then the V2 here we expect to be a little slower, okay? So then this gives us Zo A1 V1 is equal to Zo A2 V2, okay? So that, the constant, right? So the constant mass flow rate, right? That is your equation of continuity. Okay? All right, so we're not going to talk about volume flow rate right now. But obviously, if you cancel the Zo, right, that would drop your cell down to the volume flow rate, okay? So that will be the A1 V1 equal to A2 V2, okay? So that one, it's when the Zo is constant, right? And it's another form of equation of continuity when the Zo is constant, okay? So you have two forms here, okay? All right, bye-bye. Until next time.